Industrial age started, carbon dioxide increases. You see, the first point is anthropocentric and natural carbon emission. There's two main sources of carbon emission, and it's the anthropogenic and natural. It's human-made and nature-made of carbon emissions. The second one, the more carbon dioxide present in our atmosphere, it increases the presence of carbon dioxide in our atmosphere. As this the graph shows from Science ABC 2020, from year 2007 to 2019. From 2007, the carbon dioxide parts per million started from 380. 2019, it's up to 410 parts per million of carbon dioxide. There's a pretty high amount of carbon dioxide presence in our atmosphere. The next point is trapping heat. As the experiment has been done, it shows the carbon dioxide trapping heat in the earth. When the solar radiations enter the earth, carbon dioxide trap it for a long time in our earth and making our average temperature increases. From trapping of carbon dioxide of solar radiation in our earth, this is the impact or the final issues of carbon dioxide. It includes global warming and the increasing of global average temperature. And you see the graph, the trend, from small to large, it represents the amount of carbon dioxide present in the atmosphere. The more carbon dioxide present in our atmosphere, the more global warming or more increasing of the global average temperature. This is the relations to part of my experiment, the global average temperature. Thank you. I will give it to Sami.
Hi, I think our experiment hasn't react or something. I don't know. Should be reacting by now, but it's not. There should be a yellow line at the top of the water, but it's not really working right now. Yeah, but however, so these two I have mentioned before, the baking soda and the vinegar. It is when they mix, they produce carbon dioxide gas. Well, we didn't have enough BDP. I don't know, but maybe that's why it's not changing. So so when it changed to the surface become yellow or something brown like that, it's because carbon dioxide is reacting with the seawater at the bottom. However, because vinegar is acidic and baking soda is base, so that's why we added them together to produce carbon dioxide gas. But in our experiment it didn't. However, we can go to the graph now and see. So this will be the bar of my graph. This side is the pH, and this side is the years from 1940 to 2030 plus, and so on, so on. And this is the trend of the graph. So before, the number on this side 8.1 to 6 and below, it means so from before the industrial era, the pre-industrial era, it was 8.2. The pH was 8.2. From there it decreases to 8.1. That's why we have 8.1 as the maximum. However, we put 6 and below because as ocean acidification occur, it will go below 7 because 7 is neutral. So the causes is anthropogenic and natural carbon dioxide emission from the cars and factories, they release carbon dioxide gases and other greenhouse gases, which contribute to the formation of carbon dioxide. And carbon dioxide goes both ways. So there's a diffusion that goes to the atmosphere, which my colleague have discussed in temperature. So 30% or so, they go into the ocean straight away. And carbon dioxide that goes into the ocean, diffuses into the ocean, they react with seawater. And they produce a weak acid called carbonic acid. And from there, when an acid reacts with seawater, the pH drops, meaning that the carbonate ions decreases, and the acidity of the ocean pH increases because there's more hydrogen ions present in the ocean. And then from there to ocean acidification. So this impact is very significant, as we can all see here, even though it's small, but it's all white. That's called chloral bleaching and dying of corals when it's white. So even though if the experiment didn't work, I don't think the experiment really worked. So I will ask my colleague. So we did an experiment on a coral fragment, and it was done on Sunday. This was done on Sunday with 25 mils of seawater plus vinegar here. So we put the coral fragments inside. It's maybe you can see there's no more corals inside. This is just to represent if our experiment here didn't work, but this is what happened in the ocean as ocean acidification happened. This is the corals. It's all decayed in the water. We put vinegar and seawater because seawater is the ocean and vinegar is acidic. That's when the ocean becomes acidic. This is what happens to the corals. There will be no more corals if we continue for more years over 2030 and then over and over. And it's the same for all those that will produce calcium carbonate, which is for the shells like the kai in Fiji, kaloa in Tonga. All those things with shells, they will be when the ocean becomes more acidic, it weakens how they produce the shells. So that will impact the food web, the food chain, and then it will impact us one day. So that's how ocean acidification, how climate change impact ocean acidification, and then to the ocean, and then to us. So mainly that is our demonstration and our experiment today. Hopefully everyone understand. Thank you for our beautiful audience here for being kind and come here tonight to watch our presentation. So do you have any questions on our little presentation? You can always ask in English. Do you all understand our experiment that we did today?
Yes.
Okay. So that will be the end of our presentation, and this is our poster. We hope you understand all of it. Chris, do you have anything to add on?
This may seem this is a mess of experiments, but this is the best we got and the best we have tried to get the materials to turn on experiments. Thank you.
Yeah. Okay, thank you for your time. We'll see you later.